Hello everyone, welcome to my channel. So here today we are going to be looking at work. What is work? So we know that work is defined as the product of the force and the distance moved in the direction of the force. So let's review this definition. So it is the product of the force and the distance moved in the direction of the force. So it is not just any direction, but the distance moved in the direction of the force. Like for example, if you have an object like this one, then you apply a force of 20 newtons to move this box a distance of let's say 5 meters. Then the 20 newton force that you're applying, you are going to say the work should be equal to 20 newtons times the 5 meters. So we have 20 times 100, or 20 times 5, it will give us 100. Now the units for work is joules. So this is the work. So why have we just multiplied? Because we are saying by definition it is, in fact, it is the product. It is the product of the force and the distance moved in the direction of the force. So if someone is pushing in this direction and also the object is moving in this direction, then that means to say that will produce work. Now let's review this. So if we have this person, now we are trying to see whether or not what the person is carrying will produce any work, provided that the person is moving in this direction. So if the person is moving in this direction, there will be no work, because they are carrying something which is exerting a force downwards, but they are going in the other direction. So the force of gravity is exerting the force downwards, and also this object that is here, acted upon by the force of gravity, is acting downwards, but the person is moving in this direction. Then that means to say no work is produced. So this is very, very cardinal and important for us to understand the concept of work, energy, and power. So the distance has to be in the direction of the applied force. Let's solve some questions. Let's begin with this simple question. If we have a particle undergoes a displacement of s, should be equal to this, provided with vectors, during which a certain force F with this acts on it, finds the work done by the force on the particle during the displacement. Also find the angle between the force and the displacement. So if you are provided with vectors, the work is equal to its dot product. So F dot whatever the other unit is, so F dot S, so the dot product is equal to the work. So the work is equal to the dot product. So we have the force here, which is equal to, we have these, we can say 5I plus our 2J minus our 3K, like that, multiplied by our S, which is this. We have our 2I plus 3J plus 4K. So what we are going to do now is multiply. So just look at which ones are similar. So this one is 5I, multiply it with another one with I, so which will give us, now ignore the letters, so we have 5 times 2, it will give us 10. Just write the number. Then when we multiply our 2J times our 3J, we are going to have a positive, since both are positive. 2 times 3, it will give us 6. Again, we are going to multiply our negative 3 times our 4. This will give us a negative 12, like that. So we are going to have 10, or we have 16 minus 12, which will give us a 4, like that. So 16 minus 12 gives us 4. So this will be our work. Then the other part, we are also told to calculate the angle between the force and the displacement. So to find the angle, we use the dot product, which gives us F dot S should be equal to the magnitude of F times the magnitude of S times the cosine of the angle between them. So they want us to find the angle, so we are going to divide over our magnitude of f so that we can cancel them on both sides. Magnitude of f, the magnitude of s, like that. So after doing this, we are going to end up with our cosine of theta should be equal to f dot s over our magnitude of f times the magnitude of s, like that. So this is our cosine of our theta, like that. Then what we are going to do is we are going to find the size of each angle, or the size of each thing, where we have the s is equal to this. We need to take it, so we are going to have, let me first write it here. So we have our s should be equal to 2i plus our 3j plus our 4k, like that. So we have this. So taking this, we are going to find the magnitude. That's the meaning of s, absolute value of s. So the magnitude of s should be equal to, we are going to have the square root of our x squared plus our y squared plus our z squared, where x is the one with I, j is the y, then the one for k is the z axis. So we are going to have the square root of, we have the 2 squared, then we have our plus our 3 squared, then we have our 4. So we are going to have 4 squared, like that. So this gives us the square root of 2 squared is 4 plus 3 squared is 9 plus our 4 squared is 16, like that. So when we add this, we are going to have 16 plus 9, it will give us 25, plus 4, it will be the root of 29, like that. So this is the magnitude of s. Then the magnitude of our other angle, which is, let me write it again, then lift it. We have the f, which should be equal to 5i plus our 2j minus our 3k, like that. So this will give us a value that is equivalent to, let's find the absolute value. So we are going to put the magnitude of f should be equal to the x squared plus the y squared plus the z squared, like that. So our x is equal to, we have our 2 squared plus our y is equal to, we have x squared is 5 squared plus our 2 squared plus our z is equal to negative 3 squared, like that. So when we add these, we are going to have 5 squared is 25 plus 2 squared is 4, then we have plus 9. So if we add these, we are going to have the root of 25 plus 4, that's 29, plus 9, that will give us a value of 38, like that. So these are the values that we have, the root of that. So now we are going to say, we know that the f dot s, we have said that over the magnitude of f times the magnitude of s will be able to give us the cosine of the angle theta, like that. F dot s, if you recall, it is 4 joules. Then we divide over its magnitude. The magnitude of f, according to this, is the magnitude of f is equal to root of 38. Then we multiply by the magnitude of s, which is the root of 29. So we found the root of 29 should be equal to the cosine of the angle theta, like that. So the rules of roots, if you have 2 roots, you can just multiply them like that, so that we have, so this can be written as, if we begin with the cos, we can have the cos of theta should be equal to 4 over the root of 38 times the root of 29. I've just rearranged it, it's just the same. So multiply what is inside and keep one root. So we have 38 times 29. This gives us 1102. So we have 4 over the root of 1102. then we have the cosine of theta. Take the cosine this side, we are going to have theta should be equal to cos inverse of, we have our 4 over the root of 1102. Then we are going to find the cos inverse of 4 divided by that value. We are going to have, so when we find that, we are going to have our theta should be equal to, so if we put this in brackets, we are going to have 83.1 degrees. So this is our theta for that problem. So that is how you deal with this type. Now let's look at those other types. Let's say we have this, a 15 kg block is dragged over a rough horizontal surface by a constant force of 70 newtons acting at an angle of 30 degrees above the horizontal. The block is displaced 5 meters and the coefficient of kinetic friction is 0.3. Find the work done by the 70 Newton force, the force of friction, the normal force, and the force of gravity. What is the net work done on the block? So to answer this, we are going to have, we are told that a 15 kg block is dragged over a rough horizontal surface by a constant force of 70 Newton acting at an angle of 30 degrees above the horizontal. So the ability to solve physics problems involves you creating images, or rather the ability to work with your imagination. So we have an horizontal surface, then we have a block that is being moved, and the angle is, so we have the horizontal, it will be here. The 30 degrees above the horizontal means it is above like that. Then we are going to have our 30 degrees above the horizontal like that. So we have this force, which is the 70 Newton force acting. So now the first question that we are asked is, find the work done by the 70 Newton force. So for A, work by the 70 Newton force, so we know to say, remember by definition, work is the product of the force and the distance moved in the direction of the force. So that means to say, if we have this type of a situation, let's say we have this force, the same 70 Newton is acting. If it is acting at a diagonal angle, it means to say it has got a y component, meaning to say there is a force that is trying to push up like that, and there is an x component. But if this block continues to only move in the x-axis, that means to say all its work is in the x direction. That means to say the y direction, there is no work in the y direction, because it is not more like losing contact of this point. Unless if we had something like this where it's leaving the surface, that means to say there could be work in the y direction, which is not the case. It is only moving like that along the horizontal. It is not losing contact. That means to say all its work is in the x-axis. So the work done by that, let us find our Fy, because we are going to use them later on. Fy is equal to, remember from your knowledge of vectors, if you have the angle 30 here, then the x, let's begin with x. If you have the angle, x is the base, so it will be, this should be equal to the force times the cos. As long as the base is in touch with the angle, it will be the cos of theta. So the force is 70 cosine of the angle, which is our 30 degrees. So we are going to say 70 cosine of 30. This gives us a value of our 60.62, like that. So this is the force in the x. The force in the y will be, if this is cos, the force in the y will be cosine of our theta, which will be 70 sine of our 30 degrees. This gives us 70 cosine or sine of 30 degrees gives us 35. So we are going to have 35 newtons like that. So now the force, remember, work is equal to the force times the distance. We also attach the cosine of theta. Now be careful with this cosine of theta, and you should understand where it is used. So this cosine of theta is looking at that angle that you are looking at. Is there any angle with respect to the point of contact? Is there an angle between them? So as you can see, this x, this line in the x direction is parallel to this line. So therefore this angle is 0 in that case. So for such a situation, the angle here is 0. So we are going to have our force, which is, if we are looking at the work produced by the 70 newtons, it is only the x-axis. So we are going to use the 60.62 newtons times the distance moved. We are told that it is moved 5 meters. So we are going to multiply the 5 with the cosine of the angle between the x-axis and these horizontal surfaces. They are parallel, so the angle between two parallel lines is 0 degrees. So always remember that. It will help us in the near future. We have 60.62 times the 5. If you press the cosine of 0 is 1. So we are going to have our force will be equal to 303.1 joules, like that. So this is our work by the 70 newton is the 303.1 joules, like that. Now for the next one, it says that calculate the frictional force. So how do you calculate the frictional force? So the frictional force is equivalent to, what are we asked? Calculate the force of friction. So yeah, it was saying find the work done. So here we are saying by the force of friction. So we can say B, work of friction, work or by friction. So the frictional force does work, which will be, the work should be equal to the frictional force times the distance with the cosine of the same theta. This theta is what is the angle between. So now if we look at the cube like that, okay, let's say if we look at anything that's moving like that, one thing that we get to realize is that this thing, if it's moving in this direction, frictional force, remember, it prevents relative motion between two bodies in contact. So if an object is moving in this direction, frictional force will be acting in the opposite direction. But remember, it is this angle that is made is 180 degrees. That's how come if you press your force times the distance with the cosine of 180 degrees, it will give us a negative. Cos of 180 is negative. So we have F times distance times the cosine of negative 1, like that. So that's how come we are going to have the negative, this we just put it in front, negative F times the distance. So this is the work done. This is the work done by friction, like that. So that is basically how we find the work by friction. Now before that, let's take the cube. So we know first we need to find the frictional force. We know that the frictional force is equal to the coefficient of if it is moving, kinetic friction times the normal force. Now let's look at the free body diagram of the cube. So the free body diagram of the cube is like this. So what we have is, we have a downward force, which is the weight. We have the weight, which is our mg, like that. Then we have, since it wants to go down, there should be a force that should be pushing it up so that it does not end. So to prevent the cube from entering like that, there should be a force that is constantly pushing up like that, because the weight is pushing down. This force is the normal force. So we are going to say this will be our normal force like that. Then remember, we have another upward force which we were calling the Fy like that. So these two forces are acting up. Then we have the downward force, which is our mg. So if they are to keep in contact, because if these forces also, if they get too large, it will go up like that. So it can go up. So therefore these, the force, if you subtract the upward and the downward, it should be equal to 0. So using Newton's second law, we can say that the summation of forces in the y should be equal to 0, so that there is the maintenance of the cube in contact with the horizontal surface. So we are going to have our forces in the y. So by saying this, it means to say we are going to say, if we add the forces in the y, which will be the normal force plus the Fy, then we are going to say minus, this one is pointing downwards, minus, we have our mg should be equal to 0 like that. So the normal force, when we take the mg this side, it will be the normal force should be equal to mg. Then this one, it will be minus Fy. So the mg, our mass is equivalent to 15 kg. So we are going to say 15 kg times the gravity, which is 9.8 newtons per kg. Then we have minus our force in the y. So this force in the y is, we calculated it to be 60.62. No, we calculated 35. So we are going to say minus our 35. So we are going to have 15 times 9.8 gives us a value of 147 newtons minus our 35, which is going to give us, if we subtract 35, we are going to have 112 newtons. So this is the normal force. If you calculate the normal force, yeah, it's quite a bit hectic, but if you have background information on dynamics, this is very easy. So we are going to have our frictional force should be equal to the coefficient of kinetic friction times the normal force. The coefficient of kinetic friction in this case is equivalent to 0.3. So we are going to say the frictional force should be equal to 0.3 times the normal force, which is 112 newtons. This gives us a value of, by our 0.3, this gives us a value of 33.6 newtons. So this is our frictional force. If you know your frictional force, you can now finally say the work done by friction should be equal to the frictional force times the distance times the cosine of theta. So remember, this angle acts at 180. So we are going to have our frictional force, which is our 33.6 newtons, times the distance moved. So it was continually resisting even as it was being moved. Therefore, the total distance is the distance it moved. So according to the question, we are told that it was displaced 5 meters. Therefore, we are going to put our 5 meters there. This is going to give us a value of, if we put our 5, then we are going to have our cosine of 180 degrees. So this angle acts at 180. If it's moving in this direction, it will cause an opposing motion. So if you press everything, 33.6 times our 5 cosine of 180, this is going to give us a value of negative 168 joules. So remember, the frictional force takes away the work. This is the work done by the friction, like that. Let's look at another question. We are told that the normal force and the force of gravity. So C is the normal force. So what are we going to do? So we are going to say C, normal force. So the work done by the normal force should be equal to 0. Why is 0? Because the normal force, remember, it was acting upwards. It was acting upwards, but the object was moving in this direction. So therefore, the work done by the normal force, it was acting up, but the block was moving in this other direction. Therefore, the work done by the normal force is equal to 0 joules, because unless if the contact there was more like moved or something, that is when we can have work in such a scenario. But in this case, there is absolutely no work because it does not leave contact. The normal force is acting upwards, like that. Then also the work done by gravity. Remember, gravity was acting downwards, like that, and this block has not moved in the downwards direction. Therefore, also the work done by gravity in this case is 0 joules. Last but not the least, if we are required to calculate the work done, the net work, meaning to say the resultant, or when you add all the works, what do you have? So the net work done is equal to the work done by gravity plus the work done by the force plus the work done by the frictional force plus the work done by the normal. The work done by gravity is 0 joules plus the work done. So net work is just you adding. The work done by the force was 303.1 joules. Then the work done by the friction was negative 168 joules. Then we have plus the work done by the normal force is 0 joules. This gives us a value that is equivalent to 303.1 minus 168. This gives us a value that is equivalent to 135.1 joules. So this is the net work done. Let's look at another similar question. So this other one says, to push a 50 kg crate initially at rest across a horizontal floor, a worker exerts a constant force of 300 newtons directed at 20 degrees below the horizontal. The coefficient of kinetic friction between the crate and the floor is 0.4 as the crate moves 3 meters. Find the work done by the crate. Find the work done on the crate by the worker, friction, gravity, and the normal force, the total work done, and also the speed of the crate using the work energy theorem. Very interesting. So how do we answer this? So we are told that another crate was being moved on an horizontal surface. Now the angle was directed at 20 degrees below the horizontal. So if we have the horizontal like that, then we have an angle like that. So the angle 20 degrees below the horizontal, that's the meaning. So this was the force, which was the constant force, which was 300 newtons. So this is what we have. So firstly, to calculate the work done by the worker, we need to know we are using the same principle. Remember, this crate is moving in the x direction. So remember, this is directed at an angle like that. So this is where the 20 is. So the x is that one. Now the y, it won't be going up because the angle is below. So it will be, y will be fy like that. Now as we can see, despite all this, the crate is only moving purely in the x-axis. So therefore the work is done in the x-axis. So let's just find our fx and our fy. So fx will be equal to, we are going to have the force with the cosine of the angle theta, like that. So this force will be equal to, we know that this worker is applying a constant force of 300 newtons. So we are going to say 300 newtons with the cosine of our theta is 20 degrees. In fact, we can put the negative 20 degrees since it's below like that. But the cos of a negative value is the same as the cos of a positive value. So we can say the 300 cosine of negative 20 will still give us a positive value. So we are going to have a value that is equivalent to 281.91 like that. So this is our force in the x direction. Force in the y should be equal to f sine of our theta. So our f is 300 newtons. So times the sine of our theta is, we have negative 20. This is surely going to give us our negative, which will be the 300 cosine of our negative 20, which should be equal to 280, not cos but sine, 300 sine of negative 20. This gives us a negative 102.61 newtons. So this is the force in the y like that. Now it's very critical for you to be able to analyze. If you take this to be negative, or if you consider the negative value there, then that means to say when you use Newton's second law, you are going to add still. We are not going to say how we did it like this. What did we do? We said Fn plus Fy. If you did not consider the angle, you could have subtracted it. But if you consider the angle exactly the way it is, you are always going to be adding plus, so that the negative, you will see how it is going to play out. So with that said, we have the force in the y, we have the force in the x. We are going to answer the first part of the question, which is the work done by the worker. So work done by worker should be equal to, we have the force, work done by the worker, I'll say should be equal to the force times the distance moved in the direction of the force. So the force, it was in the x-axis, so we are going to say 281.91 newtons times the distance, which is equivalent to 3 meters like that. 3 meters. We can even add the cosine of 0 degrees because it was moving with respect to the horizontal ground. They were moving in the same direction, or they are parallel to each other to the extent whereby the angle between them is 0. So 281.91 times the 3 cosine of 0 degrees will give us a value that is equivalent to, we are going to have 845.73 newtons like that. So this is the work done by the worker. so it is purely in the x-axis like that. Then when we look at this other one, which is the coefficient, not this one, the work done by friction. So remember, friction, we can say work by friction. Remember, friction is the work by friction. So this F should be equal to the product of the frictional force times the distance times the cosine of the angle theta, which changes. In this case, for friction, it will be 180 degrees. So our frictional force in this case will be equivalent to, we don't know, so we need to find it. Remember, the frictional force is equal to the coefficient of kinetic friction if it's moving times the normal force. So this gives us a value of, remember, we have, this is the box, then the downward force is the mg, up there is the normal force. Why am I not drawing it straight? So this is our normal force like that. Then we go down like that. So this is our force F x, then we have our F y, because the angle is below the x-axis. Now, if you take it down literally, that means to say there is no need for you to put the negative 20 degrees here. But if you accounted for the negative, it means to say even for, you are going to treat this as if it's going up, so that the negative itself can cancel. You will understand. So we are going to use Newton's second law. Forces in the y should be equal to 0. We don't want it to lose contact, so it should be equal to 0 so that the contact is maintained. So our force in the y, which is having the normal force like that, then adds the force in the y. That is if you accounted for this negative. If you didn't, you are going to subtract the fy. Y subtracts at that point because it is going down. But if you accounted for the negative in the angle, you are going to add. So we are going to have plus our fy. Then we have another force that was pushing down is the mg. So we are going to say plus minus the mg. So this one is pointing downwards, and we are not even accounting for its angle or anything. So that's how come we say mg like that should be equal to 0. So the normal force should be equal to mg. Then this goes the other side, it will be minus fy, which will be our force, our normal force should be equal to, we have the mass, which is equivalent to 50 kg. So we can say 50 kg times our 9.8. Then we have minus what is our force in the y. So we are going to have minus our force in the y. Since we added it and we accounted for the angle, it gave us a negative. If you recall, the force in the y is negative 102.61. So we have negative 102.61 like that. So this gives us 50 times 9.8 times 9.8, it is 490 newtons. Negative by negative is positive, 102.61, which will give us plus our 102.61. This gives us a value that is equivalent to 592.61 newtons. So this is the normal force. If that is our normal force, then we can easily say the frictional force is equal to mu k times the normal force. Our mu k is equal to, we are told that the coefficient of kinetic friction in this case is equivalent to, the coefficient between that is 0.4. So we are going to put our 0.4 like that. times the normal force, which is our 592.61, which will give us, if we multiply by our 0.4, this gives us a 237.044 newtons, like that. So this is the frictional force, like that. So if that is the frictional force, we have the work done by friction. The work done by friction will be equal to, work by friction should be equal to the frictional force times the distance times the cosine of 180 degrees. I've explained how the angle is coming about. So the frictional force is 237 point, we have 044 times our distance, which is moving 3 meters. So we are going to stick with the 3 meters. So we are going to say 3 times the cosine of 180 degrees. If you press this, this will give us a negative. So 237.044 times our 3 cosine of 180 will give us a negative value. So we can have our negative 711.132 newton. So this is work. So the unit will be joules. So this will be the work by friction. The next part is saying that, let's just move this. So the next part, if we look at it, we are going to have gravity. So the work done by gravity is equal to 0. Remember that there is no change in terms of the vertical height. So it is not going up or down like that. So therefore the work done by gravity is equal to 0. Likewise, the work done by the normal, also the normal is the contact force, the work done by the normal should also be equal to 0, because it is not changing the so like that. So it is not changing its point of contact. Therefore the work done by the normal is equal to 0. Then the total work done is the net work. So remember, the net work should be equal to the force of the work done by gravity by the work done by the frictional force plus the work done by, if we had the force, so we are going to say the work done by the force plus the work done by the normal. So this is consistent. So our work done by gravity is 0 newtons per kg, 0 joules, not kg. So we have 0 joules. Then we have plus our work done by the frictional force is negative. So the frictional force in this case, we have negative 711.132, negative 711.132 newtons. Then we have plus the work done by our force, which was what was our work done by the force? We have 592.61. So we are going to say 592.61. So this gives us, if we have 7, then we add 592.61. This gives us a value that is equivalent to, we have substituted the normal force. We want the work produced by the force. We calculated it to be 845.73. So not the 5 something. So we have 845.73 0.73 like that. This gives us our negative 711.132 then we have plus 845.73. This gives us a value that is equivalent to 134.598 joules. So this is the net work done. Now the next question was asking us to find, so this was the total work done. The last question was asking us to find the speed of the crate using the work energy theorem. So according to the work energy theorem, it states that the net work done is equal to the change in the kinetic energy. So as long as you have the net work done, it will be equal to the change in the kinetic energy. Therefore, we are going to have the net work done should be equal to the change in the kinetic energy. It means to say subtract the final kinetic energy. We know that kinetic energy is equal to half mv squared, but in this case the final will be our first one. We're going to say mv final squared minus the initial half mv squared, not f but initial squared, like that. So in other words, this was the kinetic energy final minus the kinetic energy initial. That is how you calculate the change. So this is how come we have this. So therefore, before we replace, we are going to have our half of our, we can be able to factorize. Half is common, m is common, then we are going to run with v final squared minus v initial squared. So replacing, we are going to have our half. What is our mass? Our mass is equal to, we have the mass, which is 50 kg. Then we have our velocity final squared. What information are we given? We are told that to push a 50 kg crate initially at rest, that means to say it wasn't moving. So we are going to say minus the 0 meters per second, like that. So we are going to have the net work. So we have the net work should be equal to, we have half times 50, it will be 25, times the v final squared minus 0, it will just be v final squared, like that. Now remember, the net work done is equivalent to, we are going to have the 134. Remember, it is 134.7. so the net work is the total work. If you add all the work, it is equal to the change in the kinetic energy. Now to remember this, just remember to say all the forces that are acting on an object are the ones that more like causes an object to move, which is the kinetic energy. So the work done is the one that leads to there to be the movement. So that is the one that leads to the creation of kinetic energy, like that. So that is why if you add all the work, the frictional force, the forward driving force, the gravity and all that, that is the net work done. Should be equal to, we have the 25 times v final squared. In this case, we divide 25, which is going to be our 134.7 newtons over the 25 should be equal to v final squared. We find the square root on both sides, so that the square root of v final squared, the square root of that, we are going to have our v final should be equal to 134 divided by 25. Then we have the square root of this. We are going to have a value of 2.32 meters per second, like that. With that concept introduced, It can also work very effectively on this question. We are told that a car is moving at a speed of 20 meters per second on a level ground when its brakes are applied. If it skids for 32 meters before stopping, what is the coefficient of kinetic friction between its tires and the road? So using the same formula we used, we said that the net work done is equal to the change in the kinetic energy. So in this case, we are going to say the work done by the frictional force. Remember, the net work is equal to the work done by the frictional force plus the work done by a force, if there is any force, plus the work done by the normal force plus the work done by gravity, which should be equal to the change in the kinetic energy is equal to the final kinetic energy minus the initial kinetic energy, like that. Now remember, so we have a car like this, then this car more like is moving in this direction. It travels 32 meters, a distance of 32 meters, like that. So remembering that there is no force, because the only force that is being applied are the brakes, and these brakes are the ones that are causing there to be friction. So there is no forward driving force, so therefore this force is zero. The normal force, remember, the normal force is pointing up and the car is moving in this direction, therefore the work done by the normal force is equal to 0. Then the work done by the normal force is 0. The work done by gravity is our mg, is equal to 0. So that means to say we have this force is 0, the work done by the normal is 0, the work done by gravity is 0. Then we need to calculate, so this equation becomes the normal force should be equal to, we have the final kinetic energy minus the initial kinetic energy, like that. Then we know that the frictional force, this one is you can use it the dynamics way, but this one is much easier using the work energy theorem. So we are going to have a situation where we are just going to say we know that this is equal to the frictional force times the distance with the cosine of the angle theta. So for the angle theta, it is always 180 if you are referring to friction. Why? Because friction is opposing the motion. If it's moving in this direction, it will be applying in the other direction, and the angle between that is 180 degrees, like that. So basically, this is what we are going to have, should be equal to kinetic energy final minus kinetic energy initial, like that. So with that said, we are going to have, we need to know what this frictional force is equal to. Remember, frictional force is equal to the coefficient of kinetic friction times the normal force, which will be, so if we have this, we have the normal, this force, we don't know it, but remember the normal force in this case, we are going to use, using Newton's second law, the summation of forces in the y is equal to 0 because it's not leaving the contact. So the normal force is pointing up, so we are going to say the normal force minus the mass should be equal to 0. So the normal force should be equal to, when this goes this side, it will be mg. So we have that is the normal force, mg. But remember, our frictional force is equal to the coefficient of kinetic friction times the normal force, which will be mu k, then our normal force, which is our mg, like that. So this is our frictional force, like that. So replacing that, we are going to have, if we replace this, we are going to have, where we have the frictional force, we can put this, which will give us mu k mg times the distance cosine of 180 degrees should be equal to kinetic energy final is half mv final squared minus half mv initial squared, like that. So m is common, you can cancel it throughout, so that you have your mu k g times d cosine, so 180 here it will be -1, so we can throw the negative here. D should be equal to half v final squared minus half v initial squared, like that. So we can be able to factorize. This is common, so we can be able to factorize. We have our negative mu k g times d should be equal to, we have half is common, then we are remaining with v final squared minus v initial squared, like that. Then just replace. So we are going to have our value, which is we have negative mu k times the gravity is 9.8 times the distance, so it skied for 32 meters before stopping, so we have the 32 meters. So we are going to say 32 meters should be equal to half of our v final, which is our final, it will be 0 meters per second because it stops to move at that point, minus the initial velocity. Initial velocity is equivalent to, what are we asked? What is the coefficient? So the initial we are given 20 meters per second. So we are going to put it there, 20 meters per second. So we square this, which will give us, if we multiply this, we are going to have negative mu k times 9.8 times 32. This is giving us 313.6 should be equal to half 20 to the power 2 gives us 400. There's a negative outside, so we have negative 400. 0 minus 400 is just 400, like that. Multiplying half by negative 400 is negative 200. Then we have mu k, like that, times our 313.6. We divide 313.6, 313.6. So remembering, let's not forget the negative that's here. So here, so that we have our mu k should be equal to, if you divide 200 divided by 313, this gives us a value of 0.638, like that. So this is the answer for that one. Let's look at our last problem. Okay, so we are not going to answer this, but it's the exact same question with just a change in values. A 15 kg block dragged over a horizontal surface by a constant 70 Newton acting at an angle of 20 degrees above the horizontal. So this is what we have. We have something like this. This is what we have. 20 degrees above the horizontal, so it's like this. Then we are told the block is displaced 5 meters and the coefficient of kinetic friction is 0.3. Then we are told find the work done by the 70 Newton force. So this force is 70 Newton. So Fx, so let's find our Fx. It is equal to, we have the force times the sine of x is cos of theta. In this case, it will be equal to 70 cosine of the angle 20 degrees, which will be 70 times 70 cosine of 20 degrees. This gives us a value of 65.778, like that, newtons. So this is our Fx. Fy in this case will be force sine of theta. I'm dealing with a very similar question, that's why I'm writing fast. So we have 70 sine of 20 degrees, which will be the 70 sine of 20. This gives us a value of 23.94 newtons. So work done by the 70 newton, it will be equal to, the work done should be equal to force times the distance. In this case, the force which is acting, it is purely in the x-axis because it is only moving in the x-axis. So we have 65.78 times 65.78 times the distance with which it moved. It was displaced 5 meters, so we are going to say times 5 meters. So we have 65 was x, yeah, so we have 65.78 times 5, which gives us a value of 328.9 newtons. So this is the work done by the 70 newton. The next question was the force of friction. So we are going to have the work done by friction should be equal to the frictional force times the distance times the cosine of 180 degrees. So knowing that, we know that Bart's frictional force is equal to the coefficient of kinetic friction times the normal force. So looking at the normal force, we have an angle which is like that. We have force like that. This force is distributed in the Fy and our Fx. Then the normal force pointing up. Then our gravitational force downwards, which is our mg in this case. So we are going to say the normal force, so this is our normal force, Newton's second law, summation of forces in the y is equal to 0. So the normal force plus our force in the y minus the mg should be equal to 0, like that. So this angle 20 degrees, we already know what Fy is equal to. We have already found it, 23.94. So we are going to say Fn minus 23.94 minus the mass, which is 15 kg. So we are going to say 15 kg times 9.8 newtons per kg times should be equal to 0, which gives us, we have Fn minus 23.94 minus our 15 times 9.8 gives us a value of 147. Yeah, so not minus, plus here. So this should be equal to 0. We have plus like that, unless if the angle was negative, like that. So we have our Fn 23.94 minus 147. This gives us a value of negative 123.06, should be equal to 0. So this force, we take it that side, it will be 123.06 newtons. The frictional force will be equal to the coefficient of kinetic friction times the normal force, which will be the coefficient of kinetic friction is 0.3. So we are going to say 0.3 times the normal force, which is 123.06, which will be, if we multiply by 0.3, this gives us, so we are going to have 36.918 newtons. Finally, we have our frictional force. So the work done by the friction will be equal to the force times the distance times the cosine of 180 degrees. The frictional force is 36.91 8 times the distance, which is so it moved a distance of, according to this, 5 meters. So we can say 5 cosine of 180 degrees. This gives us 36 times our 5 cosine of 180. It's giving us negative 184.59 newtons. So this is the force of friction. With that done, we are going to say our C, let's move this, which is our normal force, work done by the normal. By now we know that it's 0 joules. There's no work in that direction. D, work done by the force of gravity. For this one, it is still the same. E, work done, net work. So net work should be equal to the work done by gravity plus the work done by the normal plus the work done by the friction plus the work done by the force. In this case, gravity 0 joules plus the normal 0 joules plus the frictional force, which produced a negative work, which is negative 184 joules. Then we have plus the work done by the force, which was found to be, the work done by the force was found to be 328.9. So we are going to say plus 328.9, which will be plus 328.9 minus 184. That gives us a value that is equivalent to positive 144.31, like that. So this is the net work done. So that is how we solve those problems. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.